Okay, so ladies and gentlemen, we would want to proceed with our lesson on the classifications of waves. Okay, so basically, there are ways that waves are classified. Waves can be categorized into so many several forms. So we will have to be cautious as to how we are going to classify them now. So let's say that let's say that so in terms of let's say in terms of direction, in terms of direction. So let's begin with our classifications in terms of directions. So what I'm trying to say here is that in terms of the direction of the movement of the particles of the disturbed medium, that is relative to the direction in which the waves travel. This categorization of waves on this basis can be led to two notable types. So, in terms of classifying waves in terms of their direction of movement, these waves can be classified into two. So, we could say one can be classified into transverse waves, and two can be classified also in terms of longitudinal waves. So, in terms of the direction of movement of the wave particle, waves can be classified into two: transverse waves and longitudinal waves. Okay, so again, we want to consider the second option. So, in terms of whether the wave can move, so here we are talking about movement. Okay, first we looked at direction, now movement. So, in terms of whether the waves can move from the source to the surrounding places under or unrestricted, or whether they can be confined in a given space. I'm taking it again. In terms of whether the waves can move from the source to the surrounding places unrestricted, or whether they can be confined in a given space, these can also be categorized into two. So we could also say, in terms of movement, waves can be classified into one, progressive, or traveling. Yeah, progressive or traveling waves, and can also be classified into two: mechanical, mechanical or electromagnetic. Okay, so as to in terms of their movement, then they can be classified into progressive or traveling waves and mechanical or electromagnetic waves. All right, so let's look at the other options that there are that we are not looking at. Let's say, thirdly, yes, so thirdly, in terms of the ability of the wave to transmit energy through a medium, such can also be classified into two, into say mechanical, oh sorry, mechanical waves and electromagnetic waves. So I believe we have made some slight mistake with two. So instead of writing mechanical wave here, this should rather be traveling or stationary. So it's either it is progressive or it is static. So permit me to get rid of this. And as I get rid of that, in terms of their movement, It's either the wave particle is moving or it is stagnated. So it could be stationary or another word for stationary, standing. Yeah. So basically, this is what we are saying. We are saying that in terms of direction, wave can be classified into two: transverse waves and longitudinal waves. In terms of movement, wave can be classified into progressive or traveling waves and stationary or standing waves. And finally, in terms of the ability to transmit energy through a vacuum, then waves can be transmitted or categorized into mechanical waves and electromagnetic waves. So basically, these are all the classifications of waves. Okay, so waves can be classified into all these, into transverse, longitudinal, progressive, stationary, mechanical, and electromagnetic waves. Okay, so now let's proceed with transverse waves. Let's look at what transverse waves are. A transverse wave is basically a wave. So a transverse wave is basically a wave in which the direction of vibration of the particles in the disturbed medium is perpendicular to the direction of wave motion. I'm taking it again. So it is that type of wave in which the direction of vibration of the particles in the medium is perpendicular to the direction of the wave motion. So let's assume we have a particle. Okay, so let's assume we have a particle like that, and then this particle is undergoing a vibrational motion. So in this sense, because this particle here is performing a vibrational motion, a wave is produced. Okay, now we are saying that with transverse wave, the wave motion is horizontal. So that is the wave motion. The motion of the wave is horizontal, but the vibrational particle motion is upward or downward. So now the particle is vibrating, but the particle is vibrating up and down. Okay, so the particle keeps vibrating up and down. The movement keeps going up and down vertically. All right, but the wave motion is horizontal. Okay, so because the the motion of the particle involved in the vibration is perpendicular to the direction of the wave motion. Here, we classify this as a transverse wave. So there are so many examples of transverse waves that we'll be looking at. We'll be looking at waves in, let's say, a slinky spring displaced up or down. We could look at water waves as an example of a transverse wave. And then we could also say that all electromagnetic waves, such as visible light, X-rays, gamma rays, these are all examples of let's say transverse waves. Okay, and yeah, string waves as well. So string waves are also examples of transverse waves. All right, so let us consider longitudinal waves. So on the other hand, with longitudinal waves, the wave is the wave in which the direction of vibration of the particles in the disturbed medium is parallel to the direction of the wave motion. Okay, so what we are simply saying is that with transverse waves, the particle's motion or the motion of the particle in a disturbed medium is perpendicular to the wave motion. Okay, but when it comes to a longitudinal wave, the motion of the particle in the disturbed medium is parallel to the wave motion. All right, it's parallel to the wave motion. So, for instance, when a slinky spring with one end fixed and the free end is pushed or released, it oscillates. Okay, and the wave generates consistent, compressed, or bunched up sections of the spring called compressions with stretched out sections, also called rarefactions, in the in the in between. All right. So with this slinky spring that I'm demonstrating here, we could tell that parts of these are compressed, parts are stretched. So this part you see here is compressed, but this part here is stretched. Okay. So we have a compression, and then we have a stretched part. Okay, yeah. So part is compressed and part is stretched. Now with this example, the compressed parts are what we call the compressions, and then the stretched out parts are what we call the rarefactions. So as we can see in the diagram, the stretched out parts are our rarefactions and our compressed parts are our compressions. Okay, so these are the terms used when describing longitudinal waves. Now, finally, we want to look at some examples of longitudinal waves. Examples of longitudinal waves could be sound waves, shock waves from the earthquakes, waves in compressed slinky springs as described, and then waves in vibrating loaded springs. Okay, so we'd love to end our lessons here, and then we'll continue with the properties of longitudinal waves during our next video session. Thank you so much for your time.